Okay, so today we're going to learn how to perform operations on some functions and the composition of functions. So this first slide is actually a screenshot from your textbook. It's showing what happens when we find the sum of two functions, the difference, the product, and the quotient. Remember, whenever we do a division problem, we never want a zero in our denominator. So that's this little exclusion here saying that the g of x function can't be equal to 0. Otherwise, it would make my function undefined. So let's go ahead and try and do some of these operations. So again, for this section, I am going to go back and teach you how to find the domain from an equation, but we will not be finding the domain of composite functions. We're going to leave that for the pre-calculus class. So let's go ahead and just find the sum of the f of x and the g of x functions. So when you see the notation here of f plus g and then an x, what this is really stating is take the f of x function and add it to the g of x function. Now, these two functions that are given to you right now, there aren't any like terms. So when I go to write this, I'm just going to be putting them side by side. So this is my f of x function. This is my g of x. So I'm going to take what f of x is. I'm going to write it here. I'm going to take my g of x function, put it right here. Notice I cannot add something to a radical unless it has the same radical. So this would be my simplified answer. I can't combine any like terms. If there were no radical there, we could add 8x plus 2x and negative 9 minus 1 if there weren't a radical there. But this is in simplest form. This is how we leave it. Same thing on this subtraction. So for this one, we're going to go ahead and take the f of x function and subtract the g of x function. And again, no like terms here. So all I'm going to do is write them side by side with a subtraction sign in between. So minus 2x minus 1. For the product, if I could actually multiply it, I would. But again, I'm just going to show that it's going to be f of x, that one times the g of x. So I'll put them in parentheses, 8x minus 9 times 2x minus 1. And again, I'm not going to distribute anything. I'm just going to leave it like that for right now, just to show you sort of what we're doing here. For the g of x function, when we do the quotient, or the f of x and the g of x, again, we're not going to rationalize here. I just want to show you how you would set it up. So we would take the f of x function, put it on top of the fraction, and then take the g of x function. Our f of x function was the 8x minus 9, and our g of x function was the square root of 2x minus 1. I'm not going to rationalize. I'm just going to leave it like that. Again, we're not going to do the domain here. I'm going to do some separate examples for this. Now let's try and apply this with some things that we could actually combine some like terms. Now, notice this time there's actually a number here. So instead of before, we saw f plus g, and then this just stayed x. So if that's were the question, then what I would do is I would take the f of x function, add it to the g of x function. So again, you would take your f of x, which is x squared minus 1, take your g of x, which is 2x plus 1, and now I would combine my like terms. The only like terms I have are the negative 1 and the positive 1. So this simplified answer would just be x squared plus 2x. Now, now for the real question here, they're now telling me to take 2 and plug it in for x. Now, you can either simplify it first like I just did, and then take the 2 and plug it in for x, follow order of operations, and get 8. Or you could take the functions individually. First find f of 2, and then find g of 2. So again, take your f of x function, plug in 2, 4 minus 1, and I get 3. Take the g of x function, which is 2x plus 1, plug in 2 for x, get 4 plus 1, and I get 5. Now that I found them individually, add them up, and I still get the same answer as if I combine my like terms first. All right, now, if you get multiple questions like this, and you've already figured out what f of 2 is, and now we're just doing f of 2 minus g of 2, well, we already know f of 2 is 3, and g of 2 is 8, so now I could just subtract them and get negative 2. Composition of functions. So for composite functions, this is the symbol for it. It's got a little circle here. Don't confuse this little circle with a multiplication symbol. This is for composite functions, or the composition of functions, and this is the composition of functions f and g. So what this means is you're going to take the second letter, and you're going to take that function, and you're going to plug it into the first letter's function for x. So you plug in the g function into the f function where you see an x. If it's written this way, the composition of functions g and f, then you would go the other way. You would take the second letter's function and plug it in to the first letter's function. Yes, So here's the first example. So again, this is a little tricky at first, so make sure you're following along. So here is my f of x function. It's the 2x minus 1. And then the g of x is the 4 over x minus 1. So what we want to do here when we're doing the composition of these functions is work from the inside out. So what we're going to do is we're going to take this function and put it inside the f of x function. So the first thing I'm going to do is figure out what g of 2 is. So I'm going to take 2, I'm going to plug it into my g of x function. So I'm going to do the inside out. I'm going to take out x and plug in 2. So 4 over 2 minus 1, 4 over 1, so g of 2 equals 4. Now that I figured out what g of 2 equals, now I'm going to take what g of 2 equals, which is 4, and plug that in for x to the f of x function. So now I take my f of x function, which is 2x minus 1, and I'm going to plug in 4. Simplify, and f, the composition of functions f and g when x equals 2 is equal to 7. So you work from the inside out. You're going to first plug in and do this part of the function first. Plug in a 2 for x, get your answer, and then take that answer and plug it into the first letter's function. Yes? Instead, let's say they didn't tell us to find, and a lot of kids says, oh, it looks like it says fog. So instead, let's say they just said to do this, okay? And this is what he did. So he took the g of x function and he plugged it into the f of x function. So he took the f of x function, 2x minus 1, he took out x, and in its place, he put the g of x function, which is 4 over x minus 1. So 2 times 4x minus 1 minus 1. He simplified this first and got 8 over x minus 1, and then he plugged in the 2. And you can do that. So then 8 over 2 minus 1. So this gives you 8 over 1 minus 1. 8 over 1 is just 8, minus 1 is 7. So you could simplify it first, plug it in as an x, and then go back and substitute in the 2. Either way. So, oh, here's the next problem, and I wrote on top of it. Okay, so now we're going to do the composition of the functions g and f, and we're going to plug in a negative 3. So again, take this, plug it into the f of x function first. So again, remember your f of x function was 2x minus 1. We're going to plug in negative 3 for x. I get negative 6 minus 1, and I get negative 7. I now take that negative 7, and I'm going to plug it into the g function. And again, your g of x function was 4 over x minus 1. So g of negative 7, 4 over negative 7 minus 1. G of negative 7 gives me 4 over negative 8, which gives me negative 1/2. So the composition of functions g and f when x equals negative 3 equals negative 1/2. So you're just doing and working from the inside out. Next. All right, we're not going to find the domain. Again, we're going to leave that for pre-calculus. Let's go on to the next slide. So again, they want the composition of functions g and f. And this time, no number for x. We're just going to simplify like he did. Let's do this one. So again, we're going to take the f of x function. So really what we're writing here is the g function, and in place of x, we're putting the whole f of x function. So my g function was 2 times x squared plus 5x. So every place that I see an x, I'm going to put in the whole f of x function. So this whole thing is going to go in there. So now I take 2 times 4x minus or plus 1 squared, and then plus 5 times 4x plus 1. Now I need to follow order of operations here. Do not make the same mistakes that people made at the beginning of the school year. Remember that this 4x plus 1 squared really means 4x plus 1 times 4x plus 1. So you need to FOIL this first and get 16x squared plus 8x plus 1. Still have the 2 to distribute. Over here, I still have this, which also needs to be distributed. So this becomes 32x squared plus 16x plus 2 plus 20x plus 5. I have like terms here with the 16x and the 20x and the 2 and the 5. So final answer here is 32x squared. So then add the 16x and the 20x, and we get 36x plus 7. And then that would be your final answer. Same original functions, but now we're going to switch the order. So now it's f of f and g, the composition of f and g. So again, remember your f of x function was the 4x plus 1. And the g of x function from the previous slide was the 2x squared plus 5x. So again, I'm going to take the f of x function, and I'm plugging in the g of x function wherever I see x. So I'm replacing this x with this function. So this one's a little bit easier. So 4 times, now put the g of x function in here, and then plus 1. I need to distribute, and you're done. No factoring, just leave it like that. Good? Okay, let's try one more. No, 2 more. And then we're done with this lesson. Next, again, take the f of x function and plug in the g of x for x. So my f of x function is 1 over x. I'm going to take out this x, and in its place, I'm putting this. So this just becomes 1 over 3 minus x under the radical. I'm not rationalizing, I'm leaving it just like that.
So the thing where it's like, you can't leave a radical on the bottom.
Doesn't apply for this. Okay? All right, next, yes. This is the last one. So again, take the f of x function, and it's going to get plugged into the g. So again, my two functions again, f of x was 1 over x, g of x was 3 minus the square root of x. So again, I'm going to take the g of x function. So g of x is 3 minus x. I'm going to take out this x, and in its place, I'm putting this. So it's going to become 3 minus 1 over x. I'm going to find a common denominator and simplify what's under here. So I can times top and the bottom by x on this one, and I leave it like that. Your homework is due tomorrow on this section. And then I just want to show you how to do one of the problems from homework. I'm going to show you how to do number 28. Want us to find, for part A, they want us to find f plus g when x equals 2. So just to show you how you use this, so for A, remember this f plus g, it's really saying find f of 2, find g of 2, and then add them. So what you're going to do is you're going to come over here to your table where x equals 2. The answer for f of 2 is 5. The answer for g of 2 is 4. You add them, and the answer is 9. For the subtraction one over here, so this is A. So for part B, where it's f minus g, when x equals 4. So for this one, we're going to come over here to the 4. For the f answer, it's 0. For the g answer, it's 0. When I subtract 0 minus 0, I get 0. Yes.
So
yes.
First, how can we do the thing where you take...
Because this wasn't composition. You do that when you get the answer of one and then you plug it into the other. That you'll have to do in the homework too. So like, let's say it was a composition and they said plug in f of 2 and then you got that answer and you got 5, then you would go to the 5 row. But it wouldn't work for this one. Like let's say we did 4. So let's say I said find f, the composition of f and g when x equals 4. So then if I go to the f column and get 0, then I would go to the 0 and get the, so like if it were a question like the f and the circle and the g, and let's say they said to plug in 4, I'd come here to the 0, I would see 0 as my answer, and then I'd come up to here, and then the final answer would be -1.
Would it tell you if it's a composition question or not?
It'll have a little circle in between the two letters. So instead of a plus sign or a minus sign, it's got the 0. It's got the little circle in the middle.
I just thought that was a mistake. Okay.
Okay, does that make sense? All right. Okay. I need you to look for the notes for 2-2, find domain. It's the last thing in the module. Last thing in the module. I'm going back to 2-2 and now teaching you how to find the domain from an equation. So look for that. And my iPad is frozen again.